Good morning, everybody. This is Jeremiah Dooley, and I work for SolidFire as one of the principal architects, primarily handling our reference architecture program and our virtualization and cloud platform integration. And I have Colin Devine here with me. Colin, go ahead and introduce yourself to everybody.
Hello everyone, this is Colin Devine of Red Hat. I'm a Technical Partner Business Development Manager, which means a lot of things to a lot of different people, but basically I try to make sure partners are successful with OpenStack and Red Hat. Go ahead, Jeremiah.
Absolutely. We've got a lot of stuff to get to, so we'll jump right in here. Real quickly, just as an overview, we've got a couple different parts to the presentation. We'll talk a little bit about the challenges. We'll talk a little about our respective companies and the offerings that we have, both on the storage and storage integration side, as well as all the fun stuff that Red Hat is doing. And then we'll talk about how we've put together the reference architecture, the Agile Infrastructure reference architecture, to be able to accelerate the OpenStack deployment, particularly for enterprises that are looking for scalable, reliable platforms to be able to support Tier 1 and production workloads. We're also going to have a couple different polling questions as we go through here. And I figured that we would start off with one of them here at the beginning, just so that we can kind of get a level set for everybody. And so early here on, we can make sure that everybody gets the mechanics for the questions themselves. So we'll start off with a pretty basic one here. Which do you identify as your primary hypervisor? And we're leaving that one pretty wide open. It can include test dev environments. It can include production environments. Most likely you have more than one of these that you're currently using in production. But if you had to pick one of these 5 and say which is your primary hypervisor, which one would you pick? VMware vSphere, KVM, Microsoft Hyper-V, Xen, or you're 100% bare metal and you don't know what a hypervisor is, which is also a perfectly acceptable response. So we'll give this one a couple minutes here so that everybody gets a chance. Just go ahead and click in the radio button and then submit your answer. And it looks like we've got more than half of you have already submitted answers. That's awesome. Great work. Still climbing. Still climbing. A few more seconds. All right, looks like we're slowing down, so let's go ahead and close out that poll. And it looks like VMware vSphere is still at the top of that list, but we see KVM climbing quickly. This is actually a pretty good snapshot of what we're seeing in the field as well. The KVM deployments, again, largely being rolled up underneath OpenStack environments, really have been one of the fastest climbing hypervisor platforms that we've seen customers who are using in production. So I think this is a pretty good, pretty representative look at how it is that we're seeing the world as well. So okay, so that's a good basis to go through. Good to keep in mind as we go through the rest of this. So I always like to start these presentations with kind of the challenge that we're looking at. The core fundamental here is that we've got a lot of challenges that we're facing on the enterprise IT side of it, and largely they have to do with go faster, do more, do better with less. Right? We need to deploy new applications. The application types and the deployment types change so rapidly. We need to be able to provide more agility and scalability in the infrastructure, so not just on the software platform side, but on the hardware itself. We need to be able to increase the performance and predictability of the applications, because at the end of the day, the workloads are really all the business cares about. And all of these things, these are the questions that we're being asked by customers when they say, what can you do to help me with these problems that I'm having? It's largely going to be around this imperative to innovate, this imperative to drive faster than we've been able to drive before. And partly, this is being driven by the presence of the public cloud. If nothing else, the public cloud has done a great job of showing some of the inefficiencies that IT has traditionally had, and has put a lot of pressure on how quickly things get provisioned, how easily things get provisioned, how programmatic things can be. The ability to use infrastructure as an API is something that was largely invented by and brought to the masses through Amazon Web Services. Once developers in particular get hooked on that type of consumption model, it becomes really hard to go back to submit an email and we'll provision a VM for you the way IT has traditionally been done. So this idea that the public cloud has raised the bar is something that we see with many of our customers and something that they're trying to address both internally as well as from a technology standpoint. And at the end of the day, no matter what it is that we call this, right? Every vendor has their own marketing buzzword for where it is that we're ending up, whether that's software-defined data center, cloud computing, IT as a service. All of these things boil down to what we want as consumers of IT and as provider of services to our companies is we want the next generation data center. We want to be able to provide agility, scalability, automation, and predictability out of not just the workloads themselves, but out of the platform supporting those workloads and the infrastructure that's sitting underneath those platforms. Because we have a whole new set of challenges that we want to address. In a legacy data center environment where most of us may have come from, where most of us may be today, we've got pretty straightforward challenges that we've spent a lot of time figuring out processes and figuring out vendor relationships to be able to solve. So whether that's making sure that we've got workloads isolated, making sure that we can scale up the infrastructure, being very manual in our administration, and in the scripting being kind of the extent of our automation and orchestration platform. When we start to move into these large-scale, multi-application, flexible infrastructure type platforms, all of those challenges change. It's not that they are completely different, but they're different enough that a lot of the investments that we've made in skill sets and a lot of the investments that we've made in the platforms to be able to support the legacy data centers aren't going to translate directly. So all of these things become valuable in that next generation data center. It's getting there that's the challenge. We see a lot of this IT transformation process happening every day, whether that's having to collapse silos so that we can provision more efficiently, whether it's having to look at our infrastructure so that we can scale more efficiently. The new challenges that we get from the next generation data center, once we clear those hurdles, we really start to be able to bring the benefit of that to our country, or to our companies. That's going to bring us to our second polling question here. And the polling question is, what stage are you today? What stage are you at with your OpenStack deployment? And we've given you four responses here. That you're considering OpenStack, that it's something that you've got on your radar, maybe you're in the process of getting budget for it, that you're currently testing OpenStack, so you actually have the bits deployed. You've got compute instances stood up, you're using Horizon to provision instances to test workloads. You're currently using OpenStack, so this means you actually have workloads that are relevant to your business, be those production or test dev that are currently running in OpenStack, or you're here to find out what OpenStack is. Which again, perfectly valid question. While we are waiting for those to come back, one of our other folks here on the call, Steve Walczek, who works for SolidFire, is manning the question booth. Steve, were there any questions that came up in chat that we can talk to while everybody's filling out the poll?
Yeah, so one question came in from Alok Singh. And he said, I just want to use bare metal virtualization, but want to use open source, something like KVM or Xen, and even want to use open source storage solutions if there are any to manage both. Do you have any solutions as he wants to remove VMware from his environment?
Sure, so good question. I think that you're going to see a couple of those here. Obviously KVM and Xen as hypervisors are two of the more popular hypervisors that roll up underneath whichever instance of OpenStack it is that you're using. And certainly Colin, when he goes through his section on Red Hat, you'll get some more information in that. I think that the overall question there is that there are lots of options for how to aggregate up hardware into that abstraction layer so that we can provision VMs on top of it. KVM and Xen are absolutely good, good examples of that, and there are lots of good reference architectures out there for you to be able to look at that. And I would definitely suggest, particularly when we go through Colin's section, start looking at some of the community-based distributions that Red Hat is using kind of as part of their incubation process. And we'll, if you have any questions about that afterwards, you can reach out to, reach out to any of us and ask for more information. All right, so it looks like we've got all the polling results in. This is good. Again, this is probably what we expect. There are a fair number of people that currently testing and currently using OpenStack sections have gotten very big very quick. You know, and that they are approaching the considering OpenStack version, I think, is a good sign of the momentum that we've seen. You know, that we've seen in general around OpenStack, and particularly OpenStack in the enterprise. So again, good data. Thank you for responding to the poll. That's it's good to see the audience reflecting some of the things that we're seeing out in the market. All right, so with that, we're going to jump over here into the next section, and I want to talk about SolidFire a little bit. So SolidFire is an all-flash storage array company, and we are based around the concept that the storage infrastructure needs to be as transparent and as integrated into the platform as it possibly can be. To that end, we've designed a storage array that is linearly scalable with an individual node-based architecture with no shared components on the back end, so that we can start at a small footprint and continue to scale as customers go. The scale out, both from a usable capacity and a controllable IOPS, is really you know, architecturally the key feature of what we're doing, but it gets better when it's coupled with the quality of service initiative that we've put into the array, which we'll talk about here in just a second. Much like that next generation data center, SolidFire tends to think of the things we're trying to bring to the market around these 5 pillars. Right? The ability to scale the infrastructure out linearly, the ability to provide high availability and self-healing into the infrastructure, the ability to provide guaranteed quality of service, which allows us to decouple provisioning capacity from I/O, the ability to completely automate the entire system. 100% of the interface to the system can be API driven, so we play particularly well with environments like Cinder and OpenStack, where being able to tie directly in at an API layer is a huge differentiator. And then the must-have for an all-flash array these days, which is guaranteed inline data reduction. So the dedupe compression and thin provisioning that pretty much are required to make the economics of an all-flash array platform work, having those there and having those built in. These 5 pillars are really what we're going to center all of our value proposition to the market, and particularly with OpenStack around. The first of those that I wanted to look at was the scale-out agility side. Most of us, I come from a background working for one of the legacy incumbent storage providers, and everything that we brought to the market was based around the idea of a dual controller array, and when you bought that dual controller, you knew exactly how much capacity you were ever going to be able to have. Right? You knew that pair of controllers could only support so many disks on the back end, and when you filled those disks, whether you used all the capacity or you used all of the IOPS, you had to go buy another array, or you had to forklift the controllers at the top of the array. We wanted that, particularly in our environments, at the scale side of the market, to never have that issue again. We wanted to be able to provide linear scale of both performance and capacity. We wanted you to be able to scale them up and down. So we have lots of customers who will build in a single data center and then split a cluster and move it into 2 different data centers. And then we wanted to provide a guaranteed compatibility statement that said every SolidFire storage node that we ever create that is under support will be able to run the newest version of the SolidFire storage software and will be interoperable with all of the other nodes that we've released. So taking the whole paradigm of I bought an array and I know that it's going to be obsolete at some point in the near future, and I have to stay on this wheel of continuing to buy storage arrays and upgrading them, is something that we really wanted to take off the table right up front. So the scale-out agility is one way that we do that. The problem with the scale-out agility is if you don't have the ability to provision the capacity and the IOPS separately, you get this huge pool that you can't use all of efficiently. And so we've built a guaranteed quality of service mechanism into every volume that ever gets provisioned. And as you can see here on the screen, what this gives us the ability to do is to dictate the size of the volume. And so in this case, we've got a 2 terabyte volume that we're provisioning. But then for that 2 terabytes, we're going to guarantee a minimum of 1,000 IOPS. We're going to guarantee a maximum of 3,500 IOPS. And we're going to allow this volume to burst to 8,000 IOPS if it needs to, if it's well behaved most of the time. So being able to dynamically allocate both the capacity and the I/O means that we have lots of different use cases that we can solve with an all-flash array that couldn't be solved otherwise. If you need a huge capacity block that doesn't need a whole lot of I/O, you can provision that directly here. And if you need a relatively small amount of capacity, but with a huge hundreds of thousands of I/O because it's a database or a transactional workload that you need to have that sort of throughput to, you have the ability to provision that as well, and it allows you to really start to consolidate down multiple types of workloads onto a single array. And what that gives you is the ability to take those multiple workloads and turn them into something that's a little bit more orderly. So what you see on the left is probably, for those of you who are storage administrators, is probably familiar to you. You've got everything thrown into a bucket, and at some point in the night, whether it's backups or batch processing or whatever the business process is, there are a handful of those applications that just go through the roof from a performance standpoint, and it stamps down on everybody else that's inside that same disk group. Right, so you've got this noisy neighbor that's really impacting everything else. We try to maintain those at 3 o'clock in the morning so nobody notices. But this is a problem that in a traditional storage array you really don't have any way of solving short of spreading that load across multiple storage arrays. What SolidFire gives you the ability to do is put that QoS pooling in practice so that I have volumes with a guaranteed minimum IOPS of 500, 1,000, 1,200, 8,000, whatever it is those workloads need. And now, even if one of those workloads that is getting relatively low IOPS were to go crazy and start to consume as much capacity or as much IOPS as we possibly could give it, it's not going to impact anything else that's in there. And now we've got all of these workloads, all of them running on a single array, and we really started to drive simplicity and scale into the infrastructure. Now that we've got the linear scale out, we've got the QoS to be able to consolidate stuff down. What customers are really looking for is a simplicity in how it is that you address and manage the array. Right? The days of having dedicated storage guys who all they do is train on and provision storage is largely something that we're seeing going away. And so being able to roll that automation and administration up into some tool that's being able to do that across all of my silos is really something that customers are embracing. From a SolidFire standpoint, 100% of everything a storage array does is API driven. So there is a user interface on it. It's a great user interface. We see customers, particularly in the enterprise side, use it to build volumes and make changes to QoS. But when those environments start getting bigger, and particularly when those environments start moving to OpenStack, being able to expose the API and tie that right directly into the interface that's being used by the users to deploy their instances becomes really key. And so being able to spin up virtual machines or instances faster is great, but helping to lower the operating expenses is really the key stat there. And if we can drive 67% of the cost of the operating of an infrastructure, of a storage infrastructure out of that, that's a lot of resources that you have to be able to put back into the rest of the environment. And by automating it, we take a lot of this kind of busy work, a lot of the traditional storage pieces off the table. No more performance tuning, no more caching, no more tiering, no more over-provisioning, no more RAID groups, right? No more spare drive management, all of that stuff that would typically be involved in how do I present this storage up into an OpenStack environment. We take all of that off of the table. And that really becomes where the bulk of that operational savings is. And of course, there are still companies, there are still technologists who are skeptical of the all-flash technology. Right? We know that it's changed really fast. We know that there's been a lot of advances there. And so what SolidFire wanted to do was kind of put our stamp on it and say, all of these things that you've traditionally been worried about, we are going to take them off the table for you. The first is the compatibility guarantee. Right? We have customers ask, if you're using node-based architectures, what happens when a new Intel processor comes out? What happens when new drive capacities come out? What happens when you update software? Is any of that going to leave me behind? And we categorically say no, it won't. Every future software and platform release that SolidFire has will interoperate with existing SolidFire platforms and software. So there will never be a reason for you to be forced into deprovisioning a node. Over time, nodes will get faster, drives will get bigger. At some point, it will be more cost effective to replace a node than it will be to continue to leave it powered on and drawing power, but that becomes your choice and not something that gets forced by the architecture on our side. And then the second thing we have customers ask about is FlashWare leveling. There are lots of different ways that all-flash array vendors handle this. We're just taking it off the table. If for any reason, under any workload, under any use case, you ever get an alarm on a drive that says that there's any sort of wear threshold that gets reached, we're just going to replace the drive, no questions asked. So these two things being the most common kind of industry misconceptions or industry concerns that we hear customers have specifically about all-flash. It's just designed to take those off the table. And to that choice, the tagline here is that SolidFire is the best block storage on the planet for OpenStack. It's our heritage. It's where we grew up. It's where our integration efforts are focused. And so being able to provide the deepest of the OpenStack integration, being able to provide up all of the functionality, including QoS directly as a volume type, which is unique and something that only SolidFire does today, being independently validated for interoperability with the largest and most prestigious of the enterprise OpenStack companies out there, and then just a laundry list of customer successes across multiple verticals, across multiple industries, showing that the infrastructure really does what it's supposed to do inside an OpenStack environment. So with that, we come to another poll question. Which block storage drivers would you look to integrate with your OpenStack deployment? Go ahead and pick all of the ones that you want. And while you guys are submitting your responses, I will take a look over here. And hey, Steve, any questions in the chat window that we want to address while everybody's picking their poll answers?
Yes, we had one come in that said, how would one choose an all SSD system when comparing EMC, NetApp, Whiptail, and SolidFire?
Great question, one that we hear a lot. What I'll do is, Steve, do me a favor and see if you can't pull the YouTube link to the Tech Field Day video that Dave Wright did. Dave Wright is our CEO, and at the Tech Field Day event last year, he did a great kind of non-competitive architectural overview between SolidFire, Pure, and XtremIO. And I think that those being kind of the three leading all-flash array vendors, I think that most of the information that's in there will apply to some of the other vendors that you touched on in there. I think it's a good kind of master class on why the architecture matters and what the different components are and what is important in all-flash that isn't necessarily relevant in the legacy storage environment. So if Steve, if you can pull that YouTube video and just copy a link there into the chat at some point, that would be awesome. And then it looks like one of the other questions is Jeff asking, will the presentation be available offline after it's over? Yes, the presentation is being recorded, so we'll make sure everybody gets a link to the presentation so that you can pull either the slides or the content. And we're always available if you want to follow up directly. All right, so it looks like the pull request is done. Looks like Ceph, no surprise there at all. Ceph, EMC, LVM, NetApp, yep, pretty much all of the usual. My goal is to get that 24.3% at SolidFire up significantly higher than that, and hopefully as we go through the rest of this, we'll be able to do that. The power of existing vendors for the win in that poll right there. All right. Any other questions, Steve? Are we ready to jump on?
Ready to keep going.
Okay. So at this point, I'm going to turn it over to Colin, and Colin's going to walk us through the Red Hat ecosystem and some of the fun stuff that they're working on. You want to go ahead and take it from here, Colin?
Hello, everyone. Thanks, Jeremiah. Appreciate that. So let's slide that polling aside, and we'll jump to the next slide. And give you a little overview of what I'm going to talk about today. Give you a little bit of sense of what OpenStack is. I know most people on the call are familiar, but for those who may be a little less familiar, I'm going to give a quick overview of what that is, how Red Hat offers OpenStack to its customers, what the kind of cadence of releases, so you understand this quickly moving ecosystem of technology, how we are delivering value throughout the year. And then we're going to talk a little bit about Red Hat Enterprise Linux OpenStack Platform 6, our most newest release, and some of the technology there. Scratch that service, and then we'll wrap it up and bring it back to SolidFire discussion. So, as you can see here, the Red Hat Enterprise Linux OpenStack Platform is our OpenStack offering, composed as OpenStack is of many unique individual projects or technologies that are unified in under the umbrella of OpenStack. You've got the basic necessary technology pieces, the compute, the storage, the Glance, Swift, and Cinder, the networking with Neutron. Then you've got the more advanced, sometimes optional, Salamander for your monitoring, Sahara for data processing, and Heat for orchestration. Along on the side, you got the Keystone and the Horizon dashboard. Allow you to do quite a lot of things. Underneath it all is, of course, Linux. Naturally, when we decided to choose what Linux distribution we're going to use with OpenStack, we said, there's a lot of options out there, but let's use Red Hat Enterprise Linux because it's the best, awesomest Linux distribution for enterprise customers, which is our customer base. It's optimized, co-engineered, hand-in-hand, linked in, very, very dependent. There's multiple choices in hypervisors out there. As you saw, many people are choosing KVM. We think it's the best one out there. And answer the other individual's question from earlier. If you're going to do an open source hypervisor, we think open source is pretty awesome here at Red Hat, you should look at KVM. Then had its time. Unfortunately, it didn't really flourish as quickly or come to technology functionality as much as it wanted to. And KVM has really taken the lead there. So let's move on and learn a little bit more about how Red Hat, there we go. How we release. So if you're familiar with open source process, Upstream Craziness releases their technology every 6 months through a series of meetings and processes. They release source code. Red Hat takes that source code, recompiles it into a very consumable version. It's our Upstream project, open source. Of course, you can download it, you can play with it. It's called RDO. Still upstream, still based on RHEL and CentOS and Fedora, and it's available about 1 week after Upstream releases, which they release every 6 months. We then go through a testing, hardening, certification, partner integration phase, and we come out with our Red Hat Enterprise Linux OpenStack platform. That's the technology we sell, and that's the technology you can buy support for. That's the one you should bet your enterprise on. 3-year life cycle, tested, integrated, certified, the best OpenStack for your enterprise. Moving on, I want to give you guys a quick sense of exactly what I just mentioned. Upstream, source code only, RDO, the follows upstream, and then delivers the binaries. These text slides are for your convenience afterwards. We release every 6 months, 3-year life cycle, and we're going to continue to increase that life cycle as we go. Right now the technology is moving so quickly that most customers and partners are saying, hey, I'd rather upgrade to the newest stuff as soon as it comes out rather than stay on a code base where the technology is getting a little stale. It's an interesting space where people are upgrading as soon as possible. Things are moving very fast. Let's jump to OpenStack 6 Tech Preview. I'm sorry, it's probably badly worded. The Tech Preview is the yellow highlighted aspects. This is, again, breaking out the components of OpenStack with a few additional services we've added in. I'm going to go into those right now. So Red Hat Enterprise Linux OpenStack Platform 6, based on the Upstream Juno release, was released in February. It's built with Enterprise Linux version 7. Of course, that's where it's built and runs your managed services from, your hosts. Also run RHEL 7, but they can support any version of RHEL back to, I think, even 3, and multiple other distributions as well. Full graphical installer, again, 3-year life cycle. Major features, of course, IPv6, SRIOV, no evacuation, multiple backends for Keystone because people love their Keystone backends. The Sahara data processing is, of course, your Hadoop integration. This allows you to do your Hadoop big data along with your OpenStack cloud. Tech previews, as I mentioned in the slide previously, are OO and Ironic, which are both software components that help you enable your hardware and are highly integrated into our installer and manager. So they allow you to automatically detect and provision hardware technologies in your environment. The plan for the near future is that you've got your OpenStack distribution running, everything's going fine. You start maximizing all of your VMs. You think, I need to grow this because I've got more work to take care of. You roll in a new rack of hardware with some SolidFire storage in it. You plug it in, and the software automatically detects, provisions, installs, and moves VMs over there for you to automatically start working. That's the future. That's where we're going. We're not far from there. It's going to be a pretty amazing time when we get there. The Red Hat community is focused majorly on OpenStack. As you probably know us as a Linux company that we are. We're also a major OpenStack company. As you can see from the slide in front of you, huge commitments in terms of code upstream. When we say we're part of a community, it means it's not just marketing, it's not just talking big talk, it's code commitments. It's making upstream work so that downstream can then function in your environment. That's how we drive value. How else do we do that? Well, of course, we do the integration with our cloud, OpenStack Cloud Infrastructure Partner Network, making sure we've got all of our major partners that you can think of out there certified, including SolidFire. Easiest way to think about it for a hardware perspective is if it works on RHEL Linux, it'll work on OpenStack. And from a software perspective, we've got a great web page out there on certifications where you can test. We can find out what the new certification level is for every partner. Last slide, I like to kind of show how Red Hat works. Right, you've got upstream craziness, 100,000 projects up there, people writing code on their own for companies and in their parents' basements. We take that, we push it through projects that kind of solidify and wrap a little bit of normalcy around that. That's that middle tier with a Fedora for upstream Linux, for RDO, for enterprise Linux OpenStack platform. Of course, all of our other products that we sell have upstream. And then we take and make that consumable for the enterprise. That's the magic of Red Hat. We make upstream craziness open source software consumable for your enterprise, giving you the value of the functionality and community-driven innovation in a way that's consumable for your enterprise. With that, I'm going to hand it back to Jeremiah. Keep it going.
Good stuff. So we're gonna finish up here. I love watching all the Red Hat stuff kind of come together. That last slide around how you guys filter out all the noise of upstream is pretty amazing. We're actually going to finish up here with a poll. So the question is, when considering OpenStack as your cloud management platform, what criteria is the most important to you? You may pick two of these. And while everybody is updating the poll questions, we'll open up the platform to any questions. Does anybody have any questions about Red Hat, about OpenStack, or anything that Colin can dig into here real quick?
I'm going to jump back to that original question about the OpenStack and the VMware individual had. It's a great question. I think we're seeing that so often. This is the group we have today, as you mentioned, Jeremiah, highly representative of the people that I see on a regular basis. Just in terms of OpenStack knowledge, it wasn't much more than a year ago. It was 60-70% were familiar but not running it, and 20-30% were actually running it, and that's switched. Right now, you get 60-70%. Using it, testing it, even running it in production, and then the trailers are becoming more familiar with it. So in just a year, that's switched entirely. And what I hear all the time is customers saying, hey, we love VMware. We get a lot of value out of them over the years, but it's not 2008 anymore. Virtualization is kind of a solved problem in our industry. Where is my value being delivered now for my vendors? And the answer there is let's look at your problems. It's not virtualization that's solved. Let's look at managing your entire data center from networking to storage to compute with one tool. Right? That's what OpenStack gives you, and SolidFire makes that storage scream. It's the networking and the virtualizations are tricky, but the storage, once you plug in a great partner like SolidFire, just makes it real easy, and you get the performance that you need for your applications. Awesome.
Yep, and that's actually a good segue. Mahesh asked the question, OpenStack is a para-virtualized or host-assisted. OpenStack is actually the management platform that sits above the hypervisor. The hypervisors are there are many of them. Red Hat includes their hypervisor in there, but most of those are going to be you get your pick, right? So you can install them in para-virtualized mode. You can install them in hardware virtualized mode and let it use the hints and the tricks that are included in the Intel processors to be able to do that. So just from a stack standpoint, OpenStack is one step above the hypervisor. The hypervisor sits underneath it. From an OpenStack standpoint, there are many hypervisors that can be used from a Red Hat standpoint. That hypervisor can be either para-virtualized or hardware assisted. And it looks like we just had one last question come in. Hello, can you speak about RDO integration with vSphere? Is that something that you can do, Colin, or is that something that we need to talk to Michael Gale about taking offline?
I'm gonna give you a very high-level kind of answer to that, because I think that question can go about 14 different directions. And then I'm going to invite that person to follow up with us afterwards. So RDO, of course, is the upstream project that we work on. Of course, the downstream, the thing you can buy from us and get support and run with confidence in your enterprise is RHEL OSP. Marketing people hate us when we say RHEL OSP. They say to always say it, spell it all the way out. So I'll say Red Hat Enterprise Linux OpenStack platform. And that's what you want to look at. We do provide, as Jeremiah just mentioned, we support, of course, our KVM technology, which we think is the best open source hypervisor technology out there. But we do integrate with VMware's VSX through their driver. So if you have VMware and you really like that hypervisor technology, we have a fully supported integration there from the support teams all the way up to engineering teams, making sure that works correctly. Because we know the customers, there are some customers out there who demand that. So we've met that need for them. And let me, again, invite that person to follow up with me afterwards, and we'll answer any other adjacent questions they may have.
Yep, and so we finished up the poll question that's there, and it looks like ability to deploy quickly is the number one criteria that's important, which is, again, very reflective of what we see and part of the reason that we put webinars like this together with our friends at Red Hat. And then we look at performance, we look at total cost of ownership, we look at scale, and interestingly that tees us up right directly to go into the rest of the discussion. So one last check. Any questions, Steve, before we jump into the last section of the presentation here?
No, I think we can move on, and we'll try and address some if we have time at the end. Thanks.
Okay, sounds great. All right, so the final section that we're going to talk here about is the Go Faster button. We don't call it an easy button because the easy button on the OpenStack side, Red Hat is probably as far ahead as anybody in trying to make that a reality. There's still a lot of learning curve, both on the infrastructure side and on the business operations side. So we like to call it the Go Faster button. SolidFire's Agile Infrastructure is a reference architecture program that we put together in order to make the storage and the platform that sits on top of the storage more commoditized so that you all as infrastructure people could focus more on the workloads and more on the use cases that are being deployed inside your businesses. To that end, we built a series of reference designs where we focused really heavily on being modular at all levels. In order to develop the reference design, we have to use kind of a golden master, and we partner with some of our friendly vendors to be able to do that, but we tried to make it as modular as possible, so no matter what hardware vendor, no matter what network vendor, frankly, no matter what storage vendor it is that you're using, these blueprints should still be good templates for you to be able to try to accelerate the deployment of OpenStack as fast as possible. Being able to accelerate that time to value is absolutely the #1 goal of the reference architecture program, and it gives us a great way to showcase all of the different content that SolidFire as an organization has put together for customers who are using and deploying OpenStack in the enterprise. Today, we have 2 of these reference architectures that are out. We kind of categorize them into the OpenStack reference architectures and the VMware reference architectures. Today, the one that we're going to talk about was done in conjunction with Red Hat and Dell. And for those of you who are looking forward to the conference season, which is about ready to get kicked off here, just as a little bit of a sneak preview, we will be releasing a new version of the Red Hat OpenStack reference design in conjunction with Cisco. So we'll be using the Cisco Blade servers and the Cisco upstream switches to be able to do that. So the same goodness, same time to market, we'll just switch up the hardware a little bit and give people a little bit more coverage based on what it is that they're using inside. So what do we want out of AI? Again, we're going to try to align with those 5 pillars like we talked about earlier. On the agility side, we wanted to be able to completely abstract out the pools of compute, networking, and storage. And by storage, we mean both capacity and I/O. On the automated side, we wanted to be able to get to OpenStack quickly. So with the 17 nodes that we used in our reference design, which we'll talk about here in a second, we went from 0 to bare metal OS provisioning in 30 minutes. And then we went from bare metal OS provisioning to OpenStack configured and Nova nodes registered and ready to deploy instances in another 30 minutes. So the idea here is we wanted to be able to go from 0, a stack of racked hardware, to a fully functioning, out-of-the-box Red Hat OpenStack implementation in less than an hour. And to that end, we've provided all of the scripts that we used. We've provided all of the deployment. We've provided all of the bare metal provisioning templates that are needed for that. And all of that is located in the reference architecture. Scalability-wise, we wanted to be able to provide linear scalability, not just of the storage, which is pretty easy, that's how we're built, but also of the compute and networking. How do I grow this when I need more than one cabinet, or I need more than one set of switches, or I need more compute based on the workloads that I'm supporting? Predictability, we wanted to be able to integrate QoS directly. No compromises, no add-ons, no bolt-ins, no custom versions of the Horizon dashboard. Out of the box, we wanted the Cinder driver and the Cinder integration to be able to surface QoS and all the rest of the things that the storage array can do natively. And then from an efficiency standpoint, this is largely just a function of the hardware. How efficient can we get with the footprint? How many cores? How many instances? How much storage can we fit into a single cabinet? And on that front, it looks like a cabinet of gear, right? The modular design here is not necessarily anything that anyone in this call hasn't seen before. What we were really driving for here is as much density as we could get. You know, the more dense we can put the compute nodes, the more dense we can drive the storage. We picked a pretty moderate oversubscription rate on the vCPU side. What we really wanted to do was show in an existing footprint of heat and floor space, how many instances can we drive? And if we do that, how does that impact the operational efficiencies? So lower costs, lower footprint, more IOPS per gig, the API-driven nature of it, and the native multi-tenancy are really things that help drive down that operational cost on the customer side. And from a modular standpoint, everything's a plug-in, right? Everything is a piece. So we wanted to provide modularity not just at the infrastructure layer, right? Pick whichever networking vendor it is that you're happy with. But we also wanted to provide modularity at the ops management and API client upstream. We wanted to be able to provide as much bare metal provisioning as we could, data center services, data center networks. All of these we want to be able to scale in every direction. And one of those things that we see customers challenged with a lot on the OpenStack side is how does my networking translate, particularly when coming from VMware. Frankly, the VMware networking story, how administrators set up networks and how they provision networks to instances, is a lot more transparent and obvious than it is on the OpenStack side. And so one of the things that we did was go into great detail around how do you set up the networks to be able to segregate traffic inside an OpenStack environment. How do you separate out your provisioning traffic from your storage nodes, from your compute nodes, and all the rest of the things that go in there. In this version, in the existing version, we used basic VLANs to be able to do that. All of that's being translated into neutron networking for the version of AI that is currently in process that will be rolled out here over the course of the OpenStack Summit in Vancouver, over the course of Cisco Live in San Diego, and then the Red Hat Summit in Boston. So definitely stay tuned. If you're looking for the neutron networking version of this, stay tuned for that. We'll have it out here in a couple weeks. And then the scalability doesn't just apply to the software constructs, it also applies to the hardware constructs. So being able to separate out what it is that you want to accomplish. Do you want to add OpenStack nodes from a compute standpoint? Do you want to add storage nodes? Do you need to add upstream bandwidth? Do you need to add racks? Do you need to add data centers? We wanted to be able to provide independent scaling vectors for every one of these. So what you don't ever get to is a point where you're stranding resources, whatever those resources may be, simply because you need to scale out to the next one. That's not how SolidFire works as a storage product, and that certainly wasn't how we wanted the reference architecture program to work either. So everything scales as far as it needs to until it's full, and then it scales independently from all the rest of the resources inside the environment. The other thing that we wanted to do is the hardware is great. There are people who are really excited about the hardware, but what matters to the business is the use cases that the hardware can support. For AI, for the OpenStack environments, what we really wanted to focus on was mixed workloads. It's not just one type of workload we want you to be able to run in production in an enterprise deployment of OpenStack. We want you to be able to run everything that OpenStack supports, right? Everything that it makes sense for your business to run on an OpenStack platform, we want to support all of that on a single storage environment. So from a sample use case, we chose an SDLC, test development, QA staging, large-scale web apps, so LAMP stacks, 3-tier apps, all of those kind of traditional legacy 3-tier architecture environments. Persistent block storage, so how do we do provisioned IOPS? How do we do essentially the on-premise version of EBS? How do we do the integration with the offsite? So how do we do integration with Swift or S3 compatible storage arrays to be able to do archive or to be able to do snapshots to? And then finally, databases. Databases is probably the #1 use case that we see for enterprises running on OpenStack. And so being able to do database consolidation, lots of databases on a single platform, but also being able to provide that as a service out to the end user so that they can provision instances as databases was one of the use cases that we focused on a lot. And there is a good time for our next poll question. So what percentage of your production workloads will be deployed on OpenStack by the end of 2015? My guess is that just based on where OpenStack is and where we saw some of the previous questions, that this is going to trend a little bit low, but that's okay. 10 years ago we were probably in the same place with the VMware ecosystem as well. So it'll just be interesting to see what percentage of those workloads you think will be deployed on OpenStack by the end of 2015. Steve, while everybody's answering, I think we've got time for maybe one quick question before we jump into the end of the deck here.
Yeah, question came in asking, how can the solution be able to meet the requirements of a geographically distributed compute center?
Good question. So there's 2 parts to that. The first part is the infrastructure. How does the infrastructure scale across geographies? And from a SolidFire perspective, we wanted to make sure that our arrays have as much built-in native functionality for multi-site as possible. To that end, we have the ability to do one-time replication, so basically snapshot replication on a scheduled basis. We have the ability to do asynchronous replication, so local write, local acknowledgement, and then copy to a second array across a WAN link. Or we can do synchronous replication, so local write, replication, remote acknowledgement, and then we go on with the data path. So from a multi-geography standpoint, keeping the storage backend in sync is simply a matter of how much bandwidth do you have. On the OpenStack, on the front end side of things, it looks a lot like the availability zones in AWS. right? So the applications that you're deploying need to be aware and have some sort of load balancing function that would allow them to be distributed across those multiple data centers. Again, pretty standard in the public cloud environment and translates pretty directly into a private cloud OpenStack environment as well. But good question. All right, and it looks like we're done there. And as expected, I'm actually kind of surprised. The 21 to 40% of all production workloads being deployed on OpenStack, that's pretty awesome. I think both SolidFire and Red Hat are pretty excited to see that number continue to grow as we go up there. And 20% or so above 40%, that's pretty awesome progress that we've made, I think, as an ecosystem here over the last couple of years and making that a relevant platform to deploy on. So we'll go ahead and finish up here. A couple more slides. From a validated and tested use cases standpoint, we want you to run as many of those workloads as possible. And to that end, we did we shot pretty wide with the type of use cases we're going to support, and we'll continue to expand that out as we release new and updated versions of AI. But being able to provide resource agility, being able to provide scalability, being able to provide deployment use cases are important. It's also important for us to be able to validate QoS. So being able to say, for these types of workloads, and we actually set up test scripts, and all of this is located out on our GitHub repository. We actually set up test scripts that would deploy these 6 different types of workloads with a particular type of read-write profile. And we would deploy all of them. We would allow them to inherit QoS based on the volume type that we'd put out there for them. And then we would just essentially beat them up. We'd run all of these workloads full bore, and we would show that QoS is maintaining swim lanes, that QoS is providing the protection between those workloads, even if they're different I/O patterns all on the same storage array. So being able to do that, and then allowing you to make those changes dynamically. If there's a workload that needs more IOPS, go ahead and change it. Retype the volume. Everything works great. If you need to change the capacity, respec the capacity of the volume. Everything works great. But being able to build that in natively was something we tried really hard to do to make it as easy as possible. Overall, again, the 5 things that we're trying to drive here: best of breed design, scale out in every vector, not just on the software or the storage side. Be able to provide as gentle a lock-in as we can. Again, we'd love you to stay with the hardware vendors and with Red Hat and with SolidFire, but the reference architecture will work regardless of what you slot into those. I'm confident that if we have the chance, we'll show you that we're the best block storage on the planet for OpenStack. But that's our job to prove that to you, not our job to put out a reference architecture that locks you into it. Accelerating the time to value, give you the go faster button, and then guarantee the performance. Those are the things that SolidFire is committed to. If you want to learn more, here's a couple links, and you'll be getting a copy of the slides and a copy of the presentation. So don't worry about frantically writing these down. But if you want to look at the OpenStack side of things from a SolidFire perspective, if you want to look or pull down any of the content around AI, or if you want to see a demo, we've got a great virtual proof of concept environment where we can actually show you Cinder integration, we can show you volume typing, we can show you deploying instances from a Horizon dashboard and how you would change QoS levels. And it's all pretty straightforward, but for any of you who want a demo, that's definitely the place to get it. And at the end of the day, this is our job, right? Our job is to drive the most demanding data centers, the most demanding service providers, cloud scale, enterprise. We want SolidFire to be the platform that everyone chooses to consolidate those workloads onto. We do that through the innovation. We do that through proving it, right? Proving both a business standpoint and the customer standpoint, and then doing it by providing support where our customers need to provide support. The product set, we try to keep that as simple as possible. Everything's included. Everything is a single license. Each node is a single SKU. Everything that we do on it is included. There's no additional features that need to be added, whether it's replication or snapshots or any of the rest of the things. All-inclusive feature set is something that we've stuck to our guns on because we want to make that as simple as possible, and we want to show the value of the storage software. When we can update the software and provide additional features to customers at no cost, that really helps the ROI of the platform over the long term. And again, there are 4 of these. We try to keep it as simple as possible. Each of these nodes is a Lego brick. You put the Lego bricks together however is best suited for your workloads. So from the smallest of the nodes to the largest and highest performance of the nodes, you can mix and match these to give yourself exactly the right size pool that you need to be able to support the workloads that you're supporting, and you can scale it out a single node at a time. So if you need more capacity than I/O, if you need more I/O than capacity, you just pick the node that makes sense and you slot it in there. So that is all I had. We wanted to end this kind of on an up note here. We are, as a company, SolidFire is a big believer in both OpenStack and Red Hat's execution in the OpenStack space. There's a lot of possibility there, and every day we're learning more about what it is that we can do, the workloads that are appropriate for it. I'm really looking forward to the Vancouver OpenStack Summit so that we can start to see some more stories from customers. But go do epic stuff. Whatever the platform it is that you choose, whatever the workloads you have to support, whatever your challenges are, the technology is there to help make things go faster, easier, and better. Just embrace it. Put the cape on. Go be a force of the awesome for your environments. And with that, we will go ahead and wrap it up. Thank you to Colin and the Red Hat team, and thank you to everybody at SolidFire who helped on the back end to make this possible. And as always, if you have any questions, you can follow up with us on Twitter. You can follow up with us directly. I appreciate you guys taking the time. Thank you, everybody.